Classification of data structure.
Now coming to the first we will see what is data structure or the definition of data structure. So as we had discussed in the last class, organizing the data is nothing but the data structure. How efficiently you organize your data is nothing but your data structure. So to put it in a more simple manner, so data structure is a representation of data and the operations allowed on data. If you just keep a raw data, it's of no use. So you have to process the data. When I say process the data, you have to perform operation on that to produce as the data structure. Or you can put it in another way. A data structure is a way to store and organize the data in order to facilitate the access and modification. So when I say order, so how you are going to organize your data? It is not just storing the data. So once you store the data in the memory, how you are organizing or in what order you are storing the data, so that later on you need to access those data and you need to do modification. So that is also one such definition of data structure. So in another way, if you try to relate or you want to add on to what is data structures is, data structures are the methods of representing the logical relationship between the individual data elements related to the solution of a given problem. So when we store the data, so these data, maybe in some cases they are independent, but in some cases they are related to each other. So what is the logical relationship between these data elements and how it is being used in solving a given problem? So that is how you can define it as data structure. And the last one is, it is a logical or a mathematical model of a particular organization of the data. So this is also, you can, so these are the few definitions of data structure is. So what you can see from all these definitions, so basically data structure deals with the how to store the data, how to organize the data, and how do you access these data, and how do you do the modification on these data, how do you retrieve the data, and what are the operations that you perform on the data. So this is all about the data structure is. So what you can see in several data structures, so the way in which all these operations are performed is different. Okay, finally in all the data structure, it is the data is stored in some manner and data is accessed and you perform operations, but it varies from one data structure to another data structures. The operations what is performed on each type of the data structure and how you retrieve the data in each of the data structures, what operations you perform on each of these data structures, it varies from one type of data structure to another. And some may be efficient and some may not be efficient with respect to time or with respect to, I mean to say, accessing time or with respect to memory allocation. So few of them are, I mean to say, efficient with respect to time, few are efficient with respect to memory allocation. So depending on what kind of data structure you have to choose, so that is very important. So that is what we call it as selection of data structure. So when we have several data structures, so now how do you choose which is the appropriate data structure for solving a given problem? So the choice of a particular data model or the choice of choosing a particular data structure depends on two considerations. So one is the given data structure must be rich enough in structure so that it can represent the relationship between the data elements. Okay, so when you use a particular structure for storing your data, it should provide a proper efficient structure so that it can give the relationship between the data elements which is stored in a particular data structure. So that is the first constraint. The second thing is it should be simple enough that it can be effectively processed the way the user want to modify or the way user want to retrieve or the way the user want to process the data. So if the operations becomes complex, then the user find it difficult in accessing that particular data structure. Okay, so these are the two considerations we should keep in mind whenever we choose an appropriate model for solving a given problem. So one is it should be rich enough in structure. so that it provides the logical relationship between the elements. And second thing is it should be as simple as possible so that the user can process the data. So considering these two structures, now what exactly the data structure is? So how do you classify? So what are the different types of data structures? So that is what we call it as classification of data structure. So generally data structures are normally divided into two broad categories. One is the primitive data structure and the other one is non-primitive data structure. Now, what are these primitive data structure? So this, what you can see in the slide. So this gives you the overall classification of the entire data structure which we come across. Okay. So starting from the classification of entire data structure, which is being classified into primitive data structure and non-primitive data structure. So in primitive data structures, you have basic data types like integer, character, float, pointers. And again, in non-primitive data structures, you have arrays, list, I'm going to say stack, queues, linked list, entries and graphs. So this is what gives you the classification of data structure is. Now coming to what are primitive data structure and what are non-primitive data structure. So primitive data structure, primitive means basic, okay? So generally these are the basic structures which are directly operated by the machine instructions, okay? These are not user defined. I mean to say they are available already in the machines and you just try to make use of them to operate on a particular data. And these representation or these structures varies from one computer to another depending on the architecture. So if it is a 16-bit machine, if it is a 32-bit machine, if it is a 64-bit machine, so depending on the architecture or the configuration of the machine, the primitive data structures varies from one computer to another computer. So for example, so what are primitive data structures? Okay, so what examples of primitive data structures? So all your basic primitive data types like integer, floating point numbers, character constants, string constants, pointers, they're all the examples of primitive data structures. So what you have to do is, if I want to make use of an integer data, I'll just declare it as int a or int b, int sum. So it just allocates the memory for a particular variable and you are going to do the operation on that particular data type. So these are not user defined, they're already available and these are directly dependent on the machine instructions. So that's the reason these type of structures, we call it as the primitive data structures, and they're not same in all the systems. It varies from one architecture to another architecture. For example, if it is a 16-bit machine, then the size of integer is 16-bit. If it is a 32-bit machine, then the size of integer will be 32-bit. So it depends on the architecture. So that's the reason these are machine-dependent data structures. So that's the reason they're called as primitive data structures. Coming to non-primitive data structures. So the second category of data structure is called as non-primitive data structure. Okay. So what are these data structures and why it is called non-primitive data structures? Okay, they are not machine dependent data structures. They are more sophisticated form of data structures that user can define. Okay, depending on their requirement, they can make use of these data structures. They are not machine dependent, and these are derived from the primitive data structures. Okay. So when I say these are derived from the primitive data structures, so whatever these user defined data structures, we have to associate with the primitive data structures. So that's the reason they're called as these are derived from the primitive data structure. For example, if I want to make use of an array, array is an non-primitive data structure. Now again, array, when I say it is, array tells you how the data is organized, but what kind of elements have to store it in an array? So I have to either make use of int, float, char, or double. So that's the reason these non-primitive data structures are derived from the primitive data structures. And basically these non-primitive data structure emphasize on grouping the elements, or what you call it as how to structure the elements, And when I say elements, elements can be of similar type or it can be of different data types. Like for example, an array is a collection of similar data type. Whereas I mean to say, give me an example for other thing. Structure. Structure is an example for heterogeneous data items. So when you try to group your elements, elements can be of similar types or it can be of different types. So how do you group these elements? So basically non-primitive data structure emphasize on how you are going to group these elements and whether these elements are homogeneous or whether these elements are heterogeneous. Homogeneous means same data type. Heterogeneous means different data types. So coming to examples of non-primitive data structures, you have list, stack, queue, tree, graphs. So these are the examples of non-primitive data structures. So coming to just we will have a glimpse on all these data structures. So in detail, we will be studying later on in each of the modules. But just to go with it, so you should know what each of these data structures are. So briefly, I'm going to discuss about all these data structure. So coming to the first type of data structure, it is arrays. The simplest data structure, non-primitive data structure is nothing but the array. So again, in non-primitive data structures, you have two types. One is linear and the other one is non-linear structures. So linear means it is arranged in a sequential fashion, one after the other. So I think in arrays you have seen already. So you are going to arrange the elements consecutively, one after the other, continuously. Like suppose if the first element is stored in 2000 and if the integer size is of 2 bytes, the next element will be stored in 2002 and the next element will be stored in 2004. So that is nothing but we call it as linear fashion. So that's the reason an array is an example for linear non-primitive data structure. And what exactly an array is, it's a finite number of n of similar data elements which are referenced by set of n consecutive numbers. So basically we try to group the homogeneous elements which are referenced by set of n consecutive numbers. I'm going to say locations. Okay. And again in arrays, basically like you have different types like one-dimensional array, then two-dimensional array and multi-dimensional array. So if I just go for a simple one-dimensional array, so how do you declare? So you just give the data type, the name of the array and the size. So what is very important in array is, since all the elements are of same type, that is homogeneous type, you should specify the data type of the elements, that is int in this example, and you should give the name for the elements, and all the elements in an array share the same name but with the different index position. So your ARR is the name of the array and the 10 gives you the size of the array. So when I say int ARR 10, so total you can store 10 elements and all the 10 elements share the same name ARR with a different index position, and all the elements are of integer type. So that is how arrays are used. So where int specifies the data type or the type of the elements that we store, and ARR is the name of the array, and in the square bracket what you specify gives you the size or the length of the array. So when I say 10, 10 gives you the length of the array, or what we call it as the size of the array. Now, generally when we store in an array, so elements are different. So you will have 10 different elements, but all the 10 different elements share the common name with a different position, and they are stored continuously. So how do you access the individual elements of an array? So individual element of an array can be accessed by specifying the name of the array, followed by the subscript value. So basically the subscript value, what you call, is nothing but the index value. So always the first element in your array starts from 0. So that's the reason how do you specify the first element of the array. The first element of the array will have the index 0. So if I want to access the first element, how do I name it? ARR of 0, where ARR is the name of the array and 0 is the position of the element in the array. Okay, and what will be so if I have ARR of 10, so how many elements you will have? 10 different elements. The first element will be named as ARR of 0. Second element will be named as ARR of 1. So up to what will be your last element in the array? ARR of 9. So the elements of the array will be stored in the contiguous memory locations, as I already told you. So that is the constraint in array. So if I want to store it in an array, my memory location should be continuous. If my memory is been scattered, then I cannot use arrays. Only if I have a continuous memory locations available in the heap, then I can make use of array. Then the number of elements that can be stored in an array is how many elements you can store. So how do you calculate is, it is the upper bound minus the lower bound plus 1. So in this example, what is your upper bound? 9 minus lower bound. What is your lower bound? 0. 9 minus 0 plus 1. So that is 9 plus 1 is 10. So you can store how many different elements? 10 different elements with the position starting from 0 up to 9. Now, how do you generally when we have array, so suppose if I say RR of 10, so probably you want to read the elements of the array, or you want to print the elements of the array. So since the operations what you perform will be same for all the elements in the array, so you cannot write the instruction n times for all the elements. So whether it is reading, or whether it is doing operations, or whether it is printing, so the operations will be similar for all the elements. So no matter you have how many elements in the array, whether 10 elements or 100 elements or 1000 elements, the operations remains the same, only the data varies or the element varies. So that's the reason. So we use what looping comes into picture here. Okay, so whenever array comes into picture, so we are going to make use of the constructs what is called as looping. So whatever the operation you are going to perform on the elements of the array, we are going to put within the loop. Okay, so you know, so there are different looping constructs: for loop, while loop, and do while. So the simplest one what we use most of the times in an array is for loop. Okay, so where we start with for, since the index position in an array starts from 0, we say I is equal to 0, I less than or equal to up to which position the index will have, 9th position. So I less than or equal to 9, I plus plus, scanf %d ampersand error of 5. So your scanf will be performed, or your scanf instruction will be executed how many times? 10 times. Okay, but you are going to write only once. First time your I will be 0, then you will read ARR of 0. Next time I will be incremented, so I becomes 1. Again check whether 1 is less than or equal to 9, then you will read ARR of 1. Then again I is incremented, I becomes 2. 2 is less than or equal to 9, then scanf ARR of 2. Like this, I gets incremented up to 10. 10 less than or equal to 9, the condition becomes false and you will come out of the loop. So you are going to execute this scanf instruction 10 times, starting from I equals 0 to I equals 9. When I becomes 10, scanf will not be executed because it comes out of the loop. Okay, so this is how the looping works. And please remember in your mind, whenever we use arrays, always for any operation, whether for reading or printing or doing any manipulations on the elements of the array, it has to be prefixed with for loop. Okay. Similarly, to writing an array, again, you have to use for loop with the printf statement. So first time I will be 0, then it will check 0 less than or equal to 9. Then it will print ARR of 0. So it will print the first element of the 0. Then I gets incremented to 1. So I becomes 1. 1 less than or equal to 9, is the condition true? Yes. Then it will come to the body of the loop. Then it will print the second element, that is ARR of 1. Again, I gets incremented. Then I becomes 2. 2 is less than or equal to 9. Yes. Then it comes to body of the loop, that is printf ARR of 2. So like this, the instruction will be repeated until I becomes 10. So once I becomes 10, 10 less than or equal to 9, the condition becomes false. You will come out of the loop. So your printf will be executed how many times? 10 times, starting from I equals 0 till I equals 9. So you are going to print all the 10 elements starting from ARR of 0, ARR of 1 up to ARR of 9. So this is how arrays works. I think you had studied in your previous semester, so probably. So, but this is how arrays works. Now coming to in more like what we can do with arrays. Okay, so what we saw in the previous slide tells you how data is organized. Okay, how it is stored. Okay, and how do you retrieve or how do you store the elements in an array. But what are the operations that are performed on an array? So generally, what do you do with arrays? Okay, or what are the different functions or different operations you can perform on arrays? Okay, so these are the few operations that you can perform on array. One is creation of an array. Second one, traversing an array. Third one, insertion of a new element. Fourth one, deletion of required element. Fifth one, modification of an element. And the last one, merging of an arrays. Okay, so whenever we deal with array data structures, so these are the operations you can do with arrays. One is the creation of an array. So you will not, arrays are not, I mean to say static. If you want your elements to be organized in an array, then you have to create it. Okay, so arrays does not exist. So depending on your problem, so whenever you want to store your elements in an array, you need to create it. Okay, so where you need to specify the data type of the elements, you need to specify the name of the array, and you have to give the size of the array. So how many elements you want to store. So these inputs you have to give while creating the array. So once you create the array, then what are the other operations you can do with the array? Traversing an array. So traversing an array means accessing every element of an array. Okay, so you go to every position in an array and you try to read or you try to print. So that is what we call it as the traversing of an array. Insertion of a new element. Now, what do you mean by insertion of a new element? Assume I give int a of 10. Okay, but while reading, I will read only 5 elements because I'll give for I is equal to 0, I less than 5, I plus plus, then I will read only 5 elements. But I have reserved the size as how much? Maximum size 10. So once I create an array, so in between, I can insert an element to an array at a given position. So what is very important in insertion is you have to give the position where you want to insert, whether it is at the beginning of the array or whether it is at the end of the array or whether it is at the random position in between the array. So insertion of a new element into an array. So what we have to keep it in mind is you have to specify which is the new element you are going to insert and in which position you are going to insert. So after inserting an element into an array, the existing array gets modified. So it gets shifted. So the existing elements get shifted left and towards the right also, because you're going to, depending on in which position you are going to insert. So then comes the deletion of the required element. So if you want to delete any one of the element from an array, so what is that you have to give? You have to specify which is the element you want to delete and from which position you want to go delete. So once you delete an element from an array, the size will not change. Only the thing is the memory location will be left blank. Okay, so I mean to say it will not get reshuffled. So that is what happens of an element from an array. Then modification of an element. When I say modification of an element, whatever the element you are storing, you can decrement or you can subtract. So you can perform certain operations on the elements of an array. So that is what we call it as modification of an element. And the last one is merging of an arrays. So sometimes what happens is if my numbers are too big, assume I have 10,000 numbers or assume for 1,000 numbers and I want to sort them. So what I can do is I can take two arrays. then I can sort them, then I can merge it. Okay, so this is these are the few operations which you can perform on the arrays. And probably in the next topics we will see with programming also how you can implement all these. Okay, so just keep in mind, so these are the operations you can perform on an array: creation, traversing, insertion, deletion, modification, and merging. Now coming to the next data type, what is called as list. Okay, so next we go to the second type of data structures, is called as list. Okay, so in list we have two types: linear linked list, I mean to say linear and non-linear. So here when we talk about list, generally linked list we are talking about. So linked list can be defined as it's a non-primitive linear data structure which consists of variable number of data items. Okay, again it is of similar data types. Okay, and generally any list, it will have two information, or it will have two fields. One field will store the data, and the other field will store the address of the next element. Okay, so here compared to arrays, what is different here is the memory need not be contiguous. Okay, so suppose in your computer the memory is available, but if it is not contiguous, it is being scattered across. Okay, then you cannot make use of arrays, then you can go for linked list. Okay, so when the memory is not contiguous, and when you don't know how many elements you are going to insert or delete, if you are not well defined with the size of elements, then you can go for linked list. Okay, but only problem with the linked list is it will take more space, because in arrays we are just storing the elements, but here for every one element it requires one pointer also. And what is that pointer is going to hold? The pointer holds the address of the next element. Okay, so this is how you can see. So linked list is a collection of nodes. So what is linked list? Linked list is a collection of nodes where every element in the linked list is called as a node. Okay, so what does that node contain? The node contains two information. One is the data and the other one is the pointer. So what you can see here is each of these square box, the rectangle one is a node. Okay, in that node you will have two fields. The first field contains the actual element what you want to store, and the second field is a pointer which points to the next node. Okay, so it is like linking. Okay, in Facebook, if you have an account, so you will have a friends, and your friends can have a friend of another, like it gets linked. So that's the reason where in the Facebook, like when you try to see the mutual, sometimes you will be listed with lot of friends. She or he may be a friend of you. Okay, can you invite him or invite her? How it is possible? It is because it creates a linked list of friends. Because if I am a friend of another person and that person is a friend of another person, it will try to create a link so that you will try to join it. Okay, and here in linked list, so the memory need not be contiguous. The first node can be in one memory location, the second node can be in another memory location, and the third node can be in another location. So like this you can create as many number of nodes. And this type of data structure is not static, it is dynamic in nature. Dynamic in nature means the memory will be allocated during runtime, and decision also can be changed during runtime. That means you need not define size. There's no size here. So during the runtime, you can decide whether you want to add 10 elements, 20 elements, 30 elements, 40 elements. There is no constraint for the size. So that is how the linked list is. So only the disadvantage is, and since the memory is not contiguous, and since there is no restriction for the size of the list, then how do you indicate the end of the list? How do you know this is the end of the elements? So the last node, the pointer will be null. What you can see in the diagram, the last one, the last rectangle is being indicated with that I want to say X mark. Okay, cross mark. The cross mark indicates there are no more nodes. That is the last node in the linked list. So that indicates that is the last element in your linked list. So this is how linked lists are created. So as I told you, the example is in the Facebook. So you can just have a thing. So you can have n number of nodes where each node will have two fields. One field will contain the element and one field is a pointer, and one field has to be pointer always. And what is that pointer means? What pointer is an variable which always points to something. Okay, so here the pointer is a pointer holds the address of the next node, because here the memory is not contiguous. I should know where is my next node in the linked list. It would have been stored in a different location. So how do you know in which location it has been pointed? The address of the next node will be stored in the pointer of the first node. So that is how the linked lists are created. So the first field in the node is the information field, and the second field is a pointer field. Okay. So again, if this is for singly linked list, if it is for doubly linked list, you will have another pointer towards left also, which we will see later on. Then coming to types of linked list, you have singly linked list, doubly linked list, circular linked list, doubly circular linked list. So each one of them we will study in detail when we go to that module, third module. So where we will see with the code, okay, how it is being implemented and how these linked lists are created, how you perform the operation on linked list. We take some examples and we will see with the programming. Now coming to the next data structure, what is called as stack. Now probably stack is something which we do use in our day-to-day life, keeping our books in a stack, or arranging our clothes in a stack, or I mean to say arranging plates in a stack. So probably in a day-to-day life we use this kind of data structure. Okay, so coming to technical definition of what is stack, how stack implemented, what are the operations you do with the stack. So again, stack is an example for non-primitive linear data structure. Okay, again here it is why it is called linear, because the elements are arranged in a sequential fashion. I mean to say, when I say it is not with respect to memory location, I mean to say it is arranged. You try to access linearly one after the other. You don't store randomly, or you don't store like level wise. It is one after the other. So that's the reason it is called as non-primitive linear data structure. So stack is an example for non-primitive linear data structure. And again, stack, it's like ordered collection of elements like an array. Okay, but only the thing is how stack is accessed and what operation you perform on stack is different. Okay, so stack is an ordered collection of elements like arrays, but how elements are added or how elements are deleted from the stack is different. So how it is done in stack is insertion or deletion of the elements can be done only from one end of the stack, which is called as top of the stack. Okay, so like suppose in a hotel, you would have seen arranging the meal plates. Okay, so assume you have a bottom end, that is ground floor, that is the floor. You start arranging the plates one above the other. So your ground floor is one end and the top is another end. So when you try to add a plate, from which end you will add? From the top. Or if you want to remove a plate, from where you will remove? From the top only. Do you remove the plate from the bottom? No. If you try to remove the plate from the bottom, everything will fall. So here also in stack, whether adding an element to the stack or removing an element from the stack, it is always done from one end, that is nothing but the top of the stack. In short form, or technically we say it as TOP. So TOP stands for top of the stack, TOS actually. So the other end is fixed. Please remember, in stack, one end is always fixed, that is the floor one is fixed, and on the top, either adding or inserting, you always add it from the top of the stack. So how many pointer is required? Only one pointer is required, and that pointer always points to the top of the stack. So when an element is inserted into stack, or whether an element is removed from the stack, the base remains fixed, where the top of the stack changes, because because one end of the stack is always fixed. Either adding or removing is always done from one end, that is on the top of the stack. So the top of the stack varies. Either it gets incremented or it gets decremented. If you add an element, your top of the stack gets added up, or your top of the stack gets incremented. If you remove an element from the stack, the top of the stack gets decremented, because you are removing it from an element, but the base remains fixed. So how actually stack works, or what is the principle we use it in stack? Since elements are added always from the top of the stack, or the element which is always removed from the top of the stack, the first element which is added will be the last one to remove, or the last element which is added will be the first one to remove. So that's the reason stack works on the principle of LIFO. LIFO means last in, first out. The element which is added last will be the first one to go out. So because if I add, which will be, suppose I keep on adding the plate to the meal plates in the canteen, okay, which one will I remove first? Will I remove the bottom plate or the top plate? I will remove the top plate, and that is the recently added plate. So that means the last plate which is added to the stacked meal plate will be the first one to come out. So that's the reason stack works on the principle of last in, first out. So you can see this is how stack looks. Okay, again it is an array. So for implementation, we make use of arrays. Okay, only the thing is what operations you perform on that array, it makes you stack. Okay, so generally we give a different name for insertion and deletion, because these names are similar in arrays also, it in linked list also. So just to differentiate the operation with respect to stack, we give a different name, what is called as push and pop. So what is push? Insertion of an element into a stack is called push. So adding an element into a stack is called as push. Push means you're adding an element into stack. And removing an element from the stack is called pop. So deletion of an element from the stack is called pop. So if I ask you what are the operations of stack, push and pop, these are the two important operations you perform. And what you can see in the diagram, the bottom end is fixed. It is not changing. Whether you are adding, so adding, see the arrow mark, okay, or you are popping. So both are done from the top end of the stack, which is called as the top of the stack. So this is how stack is being implemented.
Just one doubt.
Yeah, please.
Are linked lists linear? They are not linear, right?
Again, they are linear. Why it is, see, what you can see here is one thing. Yeah, linked lists are linear. The reason is not with respect to memory allocation. You try to arrange one after the other. Okay, that's what the meaning of linked list. But whereas in non-linear trees and graphs, they are not arranged one after the other. Like tree, you know how it looks. Graph, is it in the same line? No, you will have different levels. So that's the meaning of non-linear. Okay.
Okay.
Okay. Okay. Thank you.